almost, okay. Hi, good morning. My name is YC Chen, and from Taiwan Yahoo Shopping. And as we say in Taiwan, 早安,大家好. This topic is continuous integration on top of Hadoop. And I'm YC Chen, and my partner is Neil Lee. This is about a 30 to 40 minutes long talk. At first, I'll introduce who I am and what is my team. And the second, I will explain the problem we're trying to solve. And the next, I will propose my solution. And then I will show you some demo of my solution. And finally, I will have some open Q&A. So please hold your question until the end. So maybe we can start. So this is me, YC Chen. Currently, I'm not a Hadoop guy. I'm actually a release manager of Taiwan Yahoo Shopping and data team. And I'm interested in promoting open source technology in Taiwan. And this is my partner, Neil Lee. He will not be speaking today, and he is our data team's Hadoop master, or maybe the Jedi in our team. And his goal is to build an easy to sell BI platform on top of Hadoop. So at the beginning, you may be asking, okay, this guy is not Hadoop. He's a release manager. He's a release engineer. So why is he today? Does he go to a wrong place? I will try to answer the question later. Before that, I want to tell you a story. So one day, I got an urgent request. This request is to collecting this month's our shopping site's audience data from the Hadoop HDFS. Okay, it seems easy task, but because of tight deadline, so I quick modify this script, and then manually testing all the necessary testing scenario, and then quick submit to the Hadoop cluster. So I think, okay, I'm done. But because of our data set is a little bit large, so the estimated execution time is about 1 hour. So after 1 hour waiting, I checked the result and found out, oh my God, there's some mistake of my result. So I quick investigating what's going wrong, escalate Neil for the help, and then I find out, okay, there is my logical bug on my pig script. I scoop up, and then I quick modify the script, and then testing all the testing scenario. Because this bug is caused by, because of time deadline, I just manual testing the necessary scenario, but I ignore some unnecessary scenario. But this time, this unnecessary scenario screw up. So, okay, so I manual testing all scenario, and then submit again, waiting for another hours, and this time, thank God, I finished. But it should be a 1 or 2 hour task, but it turned out I caused about 4 hours to complete this task. So this is one day in the life of a data engineer. The next day, I got another request. Okay, this time is to modify the same pig script. And I didn't forget yesterday's mistake, so this time I manually test all the testing and annoying scenario. And this time I have confidence. So after I submit to a cluster, I went upstairs, get some coffee, and play some ping pong. And after that, I go back. But weird thing happened. Because this time there's not error log or exception log, it's just not complete yet. So at that point, it is hard to figure out if my code has some performance issue or it just I'm not so lucky today. Because sometimes maybe there is a lot of job there are a lot of jobs on the Hadoop cluster. Maybe it happens. So it may be run slower than yesterday. So the only thing I can do at that moment is to wait. After waiting another 30 minutes, okay, I give up. My code sucks. So it turned out I caused about 2 hours to find out, okay, my code sucks and get nothing done. So this is another day of data engineer. So because of the long execution time of our pig script, I was wondering, is there any way to figure out there is a logical bug before we actually run it? Or is there any solution to find out, is there any way to find out the performance issue before we actually submit it? So I think that is why I'm here today. I got a solution. The solution is continuous integration. So let's get started. The continuous integration is not a rocket science, and it is not one thing. The continuous integration concept first revealed in this book. This book has the same name, continuous integration. Excuse me. Okay, and it has a lot. This book proposes a lot of principles, and each of the principles is to trying to solve each area's problem. So it lists a lot of principles and try to combine this principle into one single platform, one single process. That is a continuous integration. And this time, because we don't have much time, so we only focus on what we really need to do. So in our implement, we maintain our pig code in a single source code repository that is the GitHub, and then each time we build, we automate the build and make the build self-testing. That is, we will self-testing the unit testing, performance testing, and then we testing our code in a clone of production environment. So basically, in our beta environment, we have a full stack of Hadoop cluster, and we testing the performance testing in this beta environment, and then we adopt an open source CI platform that is Jenkins. It has a fancy UI, so everyone has a Jenkins account can see what's going on, what's the current status of the build pipeline, and from the Jenkins UI. And then we automate the deployment. In our implement, we not only just auto deployment to the alpha or beta environment. Actually, we auto deployment to the production. So in the final year, I find out, okay, I'm not just implement a continuous integration, I also implement the continuous delivery. So this is the bird's eye view of my entire CI working flow. At first, we have the commit stage, human writing his code and commit to a GitHub. And the next stage, the CI platform, the Jenkins, will check out the code, and then automatically run the unit testing. And the final stage, after passing the unit testing, we know that, okay, we have no logical problem, and then we will go to the performance testing. And the Jenkins will trigger the performance testing in a beta environment. And then we go to the deployment stage. Deployment stage, in our implement, we not only push our code to the production grid, we will also do some more things. That is, we auto-generating the release document, and then we will change the issue checking system's status. So all the related issue checking system will be changed his status and auto comment some release document. And then the Jenkins will trigger the code in the production Hadoop cluster. And after the production job is done, this platform, this process will report to our user. So finally, I find out I implement a one-click deployment. That is, if once we complete our code and commit to the GitHub, and then the CI, the Jenkins, will take over. So the Jenkins will take over all the rest of the annoying stuff. So the human, the programmer, only have to concern the most valuable thing, most valuable job. That is write your awesome code, and the rest of the routine, annoying stuff will be done by the human. So after our team adopt this platform, we all feel a kind of feeling, but I cannot express this feeling in English, so I using one Chinese word to express the feeling. That is, that character is strong, and this character's feeling is just like this panda, and it is a little bit joy, happy, or between awesome, and has a little bit contentment. So after adopting this CI process, we all feeling very strong. And this is the basic tool set of our process. Okay, in the commit stage, we're using the GitHub. That is easy. In testing, we're using the pig unit, and then we're using some Maven. In the performance testing, we're using an open source platform that is the Medera. Vedia. And the deployment, our issue tracking system, we're using the Bugzilla, and in the deployment, we're using some bash script. And in the central of this process, we're using a famous CI platform that is the Jenkins. So this is a detailed system diagram. We have three environments. In the Alpha environment, we will have a CI master. That is our command center of this CI process. And in the Alpha environment, we also have a CI slave. So in the unit testing stage, the CI master will trigger the CI slave in our Alpha environment and do some unit testing job. After passing the unit testing, the CI master will push code to the beta environment. As I said before, we implement a whole stack with a full stack of Hadoop cluster in a beta environment, and we will install another CI slave in the Hadoop cluster's job tracker, because we think the CI slave job is to deliver the job, and it has the same meaning with the Hadoop job tracker. So the CI slave will get a command and deliver the job to the slave node, do the performance testing. After passing the performance testing, the CI master will say, okay, it's time to deploy to the production, and then we deploy to the gateway. So excuse me. So I will give you some deep dive of each step. First is the unit testing. Let me give you some detailed background of our team. Our team, 19% using pig script, and the rest of the staff is using the MapReduce job. So it is very trivial. We have to find a unit testing framework. So we're choosing the pig unit. Pig unit is a simple X unit framework, and when it comes to C++, we have CPP unit. When we're using the Java, we have JUnit. So it is very straightforward. When it comes to P, we're using the pig unit. And all the X unit family has the same testing scenario. That is, first we have to set up, and we will set up the testing data from the testing feature, and then we will go to the testing scenario, testing each test case, and after that we'll have tear down to release this testing data. And in order to speed up the unit testing, so in current stage we're testing our unit testing in the local mode, And then the pig unit is very, very good at unit testing, regression testing, or verifying our prototyping. So before we adopt this unit testing, the before scenario will be writing your code, testing your scenario, but by manually, and run and go. After that, the scenario change, we will have to coding first, but we will write in our pig unit testing case. And then after that, we will run our pig unit test in a local mode and push to the cluster, run it on the Hadoop cluster, and get the right result. And unit testing is not just for verifying. It has a lot of advantage. That is, unit testing is also a very good runnable live document. This true meaning is if I got a sick leave today, and nearly he has some job to modify my script, and he don't have to contact me by phone. He just have to read the pig unit script, and then he can get a lot of user requirement information from the pig unit's input and output. And then after he successfully changed my code, he can also verify the code change result by running the unit testing. So unit testing is a very good live document, and it is very flexible, because if you like me, we using the pig, we can use in pig unit, and if you writing a Mac reduce job, you can also adapt your unit testing into a CI just using the Mac unit, and Hive, you can go to the Hive test. So no matter which language, which framework you're using, there is some mapping unit testing framework you can use in this CI process. Okay, so let's go to the performance testing stage. And we're using the performance framework we're using is the Vedia. And Vedia is, in Sanskrit, Vedia means doctor, as many of you may probably know. I don't know that, so I know its pronunciation from the Google Translate. So if I have any pronunciation problem, please correct me. Okay, Vedia is a role-based performance testing, and its job to diagnose the MapReduce job's performance issue. So I think all of you know the pig and the Hive can translate into the MapReduce job. So the Vedia can also diagnose the Hive pig's performance issue, and it is a very extensible framework. So you can create your own role, or you can write some compressed role. And this is a basic performance testing stage. And in the performance testing stage, the Jenkins will trigger the pig job in a beta environment. And after it finishes, we will have the job history, and then the Vedia will take over. Vedia will read the rule-based configuration, and then get the job config and job history, and he will diagnose it. Okay, if this job has serious performance issue, and in that situation, Vedia will tell the Jenkins, and Jenkins will notify the user, and let this stage fail. But if Vedia thinks, okay, it is okay, and then we will implement another script that is transfer the Vedia's log into a JMeter's log, and then the Jenkins performance plugin will read the JMeter's log and draw a performance train. And after it finishes, we'll go to another CI stage. So I think it is time to go to the deployment part. In last 2 years, I am the release manager of the Taiwan Yahoo Shopping, and I'm hold about more than 200 release. So from this 200 release, I learned one thing. One very important thing is that deployment is not just pushing code to the production. It has many aspects to be concerned. maybe the rollback issue, maybe a document issue, or maybe a consolidation issue. So in our CI process, in the deployment part, in the first stage, we implement a push code to a production cluster. But in the rest of stage, in order to easy to roll back our code, because sometimes our code has problem, we need to roll back. So we auto create a Git tag in a GitHub. So in order to roll back, we can just easy to roll back to a previous stage, and then we will auto generating the document. So in each deployment, we will generating this release document, and we will tagging this release document into our issue tracking system. So this is the basic. This is a basic document we comment in a Barzilla. It has a repository UI, some release notes information, and we will change this issue stage from the beta to the production, and this status change will allow this issue stakeholder nodes. And this is the auto creating Git tag part. So all of the Git tag is created by the Jenkins, and then we create a type of release node that is in this release we solve the issue 1, issue 10, issue 7. So after describe all the detail, I will give you some demo about this. Okay, the demo will be in 5 scenarios. In the first scenario, I will try to make the unit test fail. I will create some syntax error and trying to make the unit testing fail. And in the demo 2, I will try to recover this fail we create and see what's going on. In the third scenario, after we complete the performance test, we will check in the performance test result. And the next, we will check in after deployment, we will check in the auto-generating document part. And finally, after all of this build pipeline finish, the Jenkins will notify to the user. So this is the base camp of the CI process. This is the Jenkins UI. And the green one is this job status is green. It will go to a rest job. But if this job is complete but fail, the color will change to red. And after this color change to red, this job fail, the rest of the step will not be done. So the color will be the blue. So we'll start our demo, and in the first of the demo, I will trying to make some error and trying to make the unit test fail. So okay, I'll create some error, and this test case is the basic pig work on script. After each commit, the Jenkins will automate check out the code and run the unit testing stage. And then we can see the current status from the Jenkins UI, and it has a fancy Ajax UI, so we can see what's going on the fly. So Because this scenario, we have to make this fail, so this test case will fail, and then the error text will be colored in the red, so we can see what's going on. And then in the next stage, I will try to fix this error and see what's going on. So I will try to recover this. Come in again. And then the Jenkins will run the unit test again. Between the waiting time, let me check the error testing result. Okay, we can see this test fail, and from this view, we can see what's going wrong. Okay, it's a success. So in the previous stage, we will see the unit testing is success, and the CI will automate trigger another stage. And in the next demo scenario, we will see the performance testing situation and see what's going on. Okay, this is the previous unit testing success result. We can see it run this test case in all success, and it all pass. Okay, and in this chart, we can see in the previous 5 build, there will be some unit testing fail. So it is time to code to the user. There is some unit test fail, and you have to fix it. Okay, the performance testing is success. So you will go to the deployment part. So this chart is a performance trending chart which we create. And every time the performance test success, the VDR will generating a log, and then we will transmit the VDR log into a JMeter log, and this plugin will generate this performance trending chart. So we can see this script has 1 or 2 peaks, but its execution time is quite stable. So it seems that it has no performance issue. Okay, in this time we have success the deployment stage, and then the CI, the Jenkins will auto generating the document and auto changing the issue tracking system status and add some node into issue tracking system. So let's check it out. So after deployment, the Jenkins will change in its issue checking season state, generating some document, and we can look back to this link and see some more information about this release. This is a code. This is a code in this release. And this is the tag we create, and this is the release document we generating. So after we check in the performance testing result, we will find that okay, the execution stage, the execution in the production environment is done. So we will go to the final demo about the notification part. Okay, after each build pipeline success, the CI pipeline will notify the user using the email, and in the email there are a lot of information about this build pipeline. So everyone who receives its email can trace back to the CI's the Jenkins UI and see the detailed information. So to be conclude, basically we create a CI process. This process will detect a logic problem or performance issue before we actually run it, and then we create a one-click deployment scenario that will revolutionize your working flow and boost your productivity. So this is our final slide. This is the Yahoo Taiwan's logo, which has a slightly different than a global Yahoo logo. So, so thank you for listening. And if you have any question, this time is open. This time is open for you. Okay.
I have one question.
Okay.
Why you hold the performance test on the cloud Hadoop cluster instead of local mode?
Okay. So you may be asking why I run the unit testing in the local mode and performance testing in the Hadoop cluster mode. The reason I using the Hadoop cluster in the performance testing mode is actually we're trying to make the performance testing environment to as similar as the production environment. So this is the concept one, and the other concept that is in our team we will routinely to sampling the data from the production to the beta environment. So we think in the production environment it is very good to using the sampling data to run the performance testing. So that's the reason. Okay.
My question is kind of related. How did you handle fixture data? Like presumably your unit tests run against some data they're expecting to be there, and you can test assertions against expected results. Like
okay.
How did you handle that?
Handle that. Okay.
Yeah.
This question is very tough. In many other language, this is also a very tough question. And basically we create our fixture data using the user requirement, and then we will trying to see is there any other situation data from the beginning, and this is our basic feature data from the beginning. And after that, after each release, if we have some issue, if we have some problem, we will add this situation in our basic feature. So the feature data will growing much much complete and less error.
Okay, and follow on. Did you ever run into test pollution issues?
Yes.
Test pollution, where you have a test that changes data, and then the next test might fail because it wasn't expecting the data to be changed in the previous test?
Yes, I think this usually happen.
Yeah, and how do you resolve that?
And the only way I can answer right now is it depends on the situation. But I think this is quite another big topic. So maybe you can reach me after this talk. Thank you.
Thank you.
In my small experience with Pig and Pig Unit, we noticed that Pig Unit has the need to run this sort of temporary cluster that's in memory as it's running, and it spins one up for every test. So our test, if we had good coverage, tended to take a while. And then some of the mocking abilities of Pig Unit, as far as mocking data goes, so you don't have to read files and things like that, was a little bit lacking. Do you guys have something that you guys have made changes to speed up your Pig Unit tests, or does it just take a while to run your battery of tests?
Okay, this because you are asking why we using the local Pig Unit in the local mode instead of using the cluster mode. Is that right?
Sort of. No, I know why you're using it in local mode. I guess I was wondering if you guys ran into challenges with Pig Unit taking a long time to run your tests.
Yes. Okay.
And being able to actually break it into smaller chunks so you can actually sort of mock pieces of your tests.
Okay.
Does that make sense?
Yes.
Okay.
So basically, in our implement, we implement our Pig. We will trying to spread out the Pig Unit test in to spread out the Pig Unit test as soon as I can. But in our implement, it seems as we don't have this kind of Pig Unit running time too long problem. So maybe so we don't have this trouble. We don't have this kind of trouble.
Okay.
So okay, thank you.
Hi. What are the different types of performance tests you have been executing on this?
Sorry, I can get your question.
Can you give me some examples of performance tests? What types of performance tests you have been executing here in this example?
Okay, so showing the performance test here, and I'm sorry. So
actually, we don't prepare the performance test in this demo. We just can explain how we use VEDIA. So VEDIA is now currently have about 50 roles in VEDIA built in. The most primary issue we encountered before is that we most encounter that we have a long running reduced task, and this problem can be diagnosed by the VEDIA. So he can tell you how there is a reduced task that running more than other times, and the reason why it's running. So maybe if you encounter this problem, you may change your pick script and change the join key or change another join methodology like replica. So it's one major primary problem we encounter and why we use VEDIA. Yeah.
Right. So in my experience, what I've seen is in MapReduce job or Pig, when you're writing tests, it's not really the code that you have to test, it's the data that causes the problem. Even if your Pig script is fine, the data that you're getting from different sources is usually not clean. So especially in the early development stages, even if your Pig test is running fine, how do you verify the final output is accurate, even if your unit test and integration test are passing? So how do you guys solve that?
And this is a very good question, but but I'm afraid I'm running out of time. But I can explain to you personally.
Okay.
Okay, thank you. Okay, so thank you for listening, and as we say in Taiwan, 谢谢大家。